Hello everyone! This video shows the computation for a convenience outlet installation. For a better understanding, we have this information. 250% is the current of full load multiplier for circuit breaker. 300% the current of full load multiplier for fuse. 200 watts is the maximum power per unit of a convenience outlet. 10 is the maximum number of units for convenience outlet per circuit. IFL represents the current of full load, PT total power, ET total voltage, that is 220 volts, CB circuit breaker, F fuse. In designing an electric circuit for convenience outlets, specific multipliers and values are used to determine the appropriate circuit protection and wiring. The full load current is calculated based on the maximum number of convenience outlets per circuit, which is 10, with each outlet having a maximum power rating of 200 watts. This results in a total power of 2000 watts. To calculate the full load current, the total power is divided by the supply voltage of 220 volts, yielding a current of 9.09 amperes. This means that if all 10 outlets are fully loaded at 200 watts each, the circuit will draw 9.09 amperes. Given this load, a 15 ampere circuit breaker may be sufficient, but a 20 ampere breaker is recommended to allow for additional capacity and prevent overloads. In practical applications, not all outlets are used at full capacity simultaneously, so diversity factors may reduce the actual current draw. Proper planning, including appropriate breaker sizing, wire selection, and load distribution, ensures the safety and efficiency of the electrical system. The appropriate circuit breaker size is determined based on the full load current, applying a safety factor of 250%. Given that the full load current is 9.09 amperes, the circuit breaker ampacity is calculated as 9.09 amperes times 2.5 equal to 22.725 amperes. Since standard circuit breaker sizes are typically available in increment of 5 amperes or 10 amperes, the nearest suitable breaker size is 20 amperes as seen in the table. This ensures adequate protection, preventing unnecessary tripping. For the wire size of number 12, AWG conductor is recommended, which corresponds to 3.5 mm squared for stranded wire and 2.0 mm for solid wire. This wire size is appropriate for carrying the expected load safety, minimizing voltage drop, and ensuring compliance with electrical code requirements. Proper breaker and wire sizing helps prevent overheating, voltage fluctuations, and potential fire hazards, ensuring safe and efficient electrical installation. The fuse ampacity is determined by applying a 300% safety factor to the full load current. Given that the full load current is 9.09 amperes, the required fuse rating is calculated as 9.09 amperes times 30 is equal to 27.27 amperes. Since standard fuse rating are available in fixed increments, the nearest suitable size is 30 amperes as seen in the table. This ensures that the fuse can handle temporary surges, which providing adequate protection against overcurrent conditions. For the wire size of number 10 AWG conductor is recommended, which corresponds to 5.5 mm squared for stranded wire and 2.6 mm for solid wire. This wire size is chosen to handle the increased fuse rating safety, reducing the risk of overheating and voltage drop. Proper fuse and wire sizing are essential to maintain electrical safety, preventing circuit damage, and ensuring compliance with electrical code standards. That's all for this video. Thank you for watching. Subscribe.